Hi, this is Matz, the creator of the language, and also the main implementer of mruby, the alternative implementation of Ruby. So today today I'm going to talk about the mruby 3.0, which is planned to be released soon, very soon. I need to be clear that the mruby 3.0 not equals to Ruby 3.0. Ruby 3.0. Recently we are very we talk a lot about the Ruby 3. So the Ruby 3 is the version 3.0 of Ruby language, Ruby the language, and also the version 3.0 of the C Ruby implementation, which is the canonical implementation of the language. We are going to release C Ruby 3.0 on December 25th this year, 2020, as a Christmas gift. In contrast, mruby 3.0 is a version 3.0 of the mruby. The mruby is the alternative implementation of the Ruby language. We have the many implementation of Ruby languages. For example, the JRuby, which is on top of the Java Virtual Machine (JVM) environment, or the Truffle Ruby, which is based on the Graal technology from Oracle Graal. Then mruby is the another alternative implementation of Ruby language. The mruby is the Ruby implementation for the embedding in scope. The mruby is plus Ruby. M stands for the embedded, or minimal, or modular, or Matsumoto's, because the early stage of the Ruby development, the multiple Matsumoto, including me, is working on. So anyway, the mruby project was started in 2010, so which is a 10-year-old project. It's kind of the old project in the open source software world, and at that time, the C Ruby was 1.9, so the language was forked from Ruby 1.9. Then the ISO standard, the Ruby was standardized by the ISO. In embedding field, especially the embedded device field, the ISO or some kind of the canonical standards is very important. So that we decided to support ISO, the Ruby international standard, which is ISO 30170 2012. But the Ruby itself, the Ruby the language evolves after the 2012. So that we add some enhancement, which were added to the language since 2012. But most of these enhancements are options, so that you can drop off everything to get the minimal implementation as a core. But you can add these enhancements to make Ruby language, mruby language, close to Ruby 3.0. But some features implemented in Ruby 3 is not implemented intentionally for some reasons. One reason is a memory problem. because of the mruby is designed for embedding, so that the memory is the biggest constraint. So the some features requires more memory, so that we had to give up those implementation. The another issue is the implementation difficulty. So that it's some features are very difficult to implement in the efficient way, so that we just gave up. Those features included in, for example, the refinements, wrapper, async fiber, pattern matching, introducing the 2.7, and the threads. We had optional library that provide a feature, threading feature, but the behavior is different because of the the mruby supports the platforms which does not have any threading support by the platform. For example, the mruby runs on the embedding OS operating system, monitors, or even without any operating system. So that those environment we cannot provide threading feature. The C extensions, the mruby does not support the C extension for cruby. So that C extension wise, those implementations are not compatible. That means that we have many Ruby gems, but we cannot use those gems from mruby. And require, so that, as I said before, some platforms does not have file systems, so that you cannot load from file systems on those platforms. So that the core does not provide the require feature or any file dependent features. All of them are optional. So the language wise, it's highly compatible to Ruby 3, except for some features I stated before. So that means that it's okay to run your Ruby code. But we don't have Ruby gems, we don't have C extensions, we don't have gems, so that the supporting libraries. But we have the different ecosystems, so that you cannot expect your existing Ruby application to run on mruby, which is the biggest difference you have to note. But instead, we have the packaging system named mruby gem, the gems for mruby. It's statically linked because of it's have to run on the platforms without file systems. And so you can use mruby to make your Ruby code run everywhere. You can embed Ruby in your application. You can run your Ruby code on the small devices, so that the broadening the possibility or programmability is one of the goal of mruby. So that everywhere means Ruby, you can run Ruby on many devices, servers, in the applications, and even games. For that purpose, the mruby is highly portable. mruby runs on the Intel machines, ARM machines, MIPS machines, Spark machines, and then many CPUs. The mruby also supports many platforms in operating systems: Linux, Android, macOS, iOS, Windows, or even without operating system. So that, for example, we have several applications that embed mruby on the, say, iOS. So that, for example, we recently see the applications named the Rubyist app which embeds mruby in it, so that you can control your iOS from using Ruby. The minimal Ruby means mruby can be minimal. The smallest memory footprint is 96 kilobytes. But you have to strip down many things. So, for example, you have to strip down the extensions. You have to strip down the regular expressions, the newer feature implemented in Ruby 3, Ruby 2 point something, 2.x, and or you may need to drop down the browser and code generators. So the only virtual machine takes 96 kilobytes. That means the mruby is designed to be modular using mruby-gem. We have the program, the tools named mgem, which manages the mruby-gems. So that you can install mgem using gem install. Then you can update the gem information from using the mgem update. Then you can take the list of the gems from the internet. If you type mgem list, you will have the many list of gems. You have the mruby processes or those many things. This is one example. Many gems. The set is far smaller than the mruby gems, which has the 20,000 or maybe, I don't know, 200,000. Many gems. But the mgem list has currently the 308 gems. It has the database gems, the operating system control gems, and many gems. Using mruby, you can run Ruby everywhere, from microcontrollers to servers. So that you can provide the programmability to users. Programmability is the key of the usability. For example, the Emacs was the editor, but the author, the Stallman, added the Emacs Lisp as a configurable programming language. By using those that programming language, so that you can enhance the editor to platform. The Emacs can run mail readers, web servers, games, and many tools supporting editing, supporting whatever you want. So the Emacs became a platform by the programmability. So you can add similar programmability to your application. So the more programmability is the key. So for example, the web servers, you can add the mruby embedded in Nginx and Apaches, and some people use mruby as a web sandbox. The Shopify provides the application of the mruby engine, which embeds mruby so that the untrusted user code can be run in safely in a sandbox. Some games embeds mruby. For example, Nier Automata embeds mruby. I've heard that. And Sid Meier's Starship is currently in development using mruby. The other things, for example, the microsatellites from the QPS lab in Japan embeds mruby, and the circling around the Earth they plan to launch the 36 microsatellites all over the globe, so that every 10 minutes, every point on Earth can be monitored. This is quite interesting challenge. Those microsatellites is controlled by mruby program. Some internet routers from IIJ Inc. Are controlled by the mruby, which provides the rules and the user interface using mruby. The CloudWalk Incorporated implemented the payment devices using mruby. And there are open source provisioning tools, Mitamae, using mruby. Mitamae is a kind of the chef-like provisioning tools, but it's single binary, so that you can copy the one binary to the client, so that you can use the provisioning as a provisioning tool. Some people use mruby as prototypes for the home appliances, vending machines, the automobile dashboard. So that these days, those systems are implemented mostly in software. So the logic in the software is getting more and more complex. So that they want to use the more productive programming language. So that they chose Ruby to implement their logics. But in production, so the required memory is bigger, and the required CPU power is bigger. So that they try to compile those logics, which is prototyped and experimented in Ruby, into C or assembly. But those trial and errors phase, the using Ruby language is make them very productive. Some hobby devices, some people try to use those hobby devices. The M5 stack, M5 stick, or BBC microbit. The second generation microbit has the more memory than the first generation, so that you can safely run the mruby on top of it. So that this is mruby. This is mruby. Then, what's new in Ruby 3.0? What's how we've improved mruby 3.0? The one thing is numbers. In mruby, integer division result in float because 3 divided by 2 equals 1.5, which was natural. But remember, so that mruby was started in 2010, 10 years ago, and at that time, I was going to change the Ruby language like that, so that integer division makes float. Well, but the compatibility issue was bigger than I expected back then. So the core teams discussed a lot and abandoned those kind of the huge incompatibility in the language. So this is the good chance to follow the CRuby path, so that we change the rules, so that make integer division makes float. And for the same reason, so the mruby result the float from the integer overflow, but we also abandoned this change, so that the float and the integer mixture was reduced in the mruby. Those are historical reasons. And we also added the rational and complex numbers to the language. They are optional, though. And we have improved the build process. For example, you can do the reg test, but at the same time, you can specify the configuration by the predefined configuration. For example, this one, mruby config, the clang async, is compile using the LLVM compiler with the address sanitizer options on. The implementation wise, the biggest change is the reduced memory. We chose the pre-allocated symbols so that you don't have to allocate many symbol tables on ROM, not RAM, so that you can reduce the RAM consumption. As a result, you can put the irep structure, which irep is the internal representation of the blocks and the methods, so that you can put those things on RAM, so that you can reduce the RAM, the precious RAM use consumption. We also improved the data structures for the hashes and the method tables and the instant variables. We also added the new methods in 2.7 and 3.0, and we fixed many bugs. And remember, so that Shopify provides the sandbox, implemented the sandbox using mruby. If it has some kind of a security bugs, it's a security bug for the sandbox. It's a hole in the sandbox. So the Shopify declare the bounty for the security bugs, so that people, especially the bounty hunters, the bug bounty hunters, found many bugs, but that we fixed them all, all reported bugs. We also registered Google's OSS Fuzz program, so that they try to put the random input into the interpreter, so that the interpreter won't clash. That we fixed them all. So that this is mruby3, which is soon to be released. So that for the further future, the mruby 3.1, 3.2, so that we have planned for the better support for the microbit and the M5 stack. So that we need to focus more on the hobby programmer using devices, so that our forerunner and the rival is the MicroPython, and then MicroPython is very strong on those devices, so that we improved support for the smaller hobby devices. And we are also working on the multi-precision integers, so that in mruby we have big nums. The integer is arbitrary precision integers, but at the moment the mruby has fixed size integers, 64 base or 32 base according to the configuration, but it's quite limited and the big difference, so that we are going to make integers multi-precision by option. For many applications, 32-bit integer is big enough, so that you don't have to spend more memory, so it's totally optional. We also are going to address the pattern matching. The pattern matching is very useful and convenient for the many cases, so that we are going to implement it in the future. This is how it goes. By using mruby, you can provide the programmability for your applications. Your application will become platform, not just an application. This is a very great opportunity or possibility of the future of your application, so that the lifetime of the mere application is shorter, for example 5 years, 10 years, but providing a programmability extend the lifetime of your applications. So that, but now you don't have to implement the scripting language for your application. Just use Ruby. Just use full Ruby using mruby. This is great opportunity for your applications. The mruby 3.0 reduce the required memory and provide more features from Ruby language. And there are more and more gems to provide the core features. And this is great possibility. We invite you to use mruby, involved in the development of mruby to enhance the future, enhance the possibility, and make the great software applications, and make the world better place and a great place to live for programmers and public general. This is the end of my presentation. So thank you, and we are going to have some kind of the QA session afterwards. So feel free to ask me any questions related to mruby or not related to mruby or whatever. Thank you. Bye bye.